So today, the SOL we're visiting and diving more into is 7.13. We're going to learn how to write algebraic equations as well as kind of dissect through the language of these word problems. But because it gets kind of tough when people try to differentiate, or let me use a different word since we're talking about words. They try to pick out and understand different words involving word problems. So what I'm going to ask you is I'm going to draw this table. We're going to try to find as many words to represent different operations within word problems, so that whenever we look at a bunch of words, we can pull away the fluff and get what we really want out of the word problem. So now this is what I want you to do. With what you know already, I'm going to give each of you 5 flashcards, or as many as you'd like. And you're going to write down as many word problem words that you can think of to represent these different operations. They can be more than one word. They can be phrases.
Just one phrase per card.
Yes. Let's try to write them on the blank side, I'm sorry, and write them kind of big. I'm messing up. Not that, guys. Because what we're going to do is we're going to try to put all these in a table that y'all created, y'all came up with, maybe fill in some blanks of common things we might see that maybe you didn't think of. And if there's any that are jumbled up, we'll move them around and make sure everything's good. Just so we have a good table to go off from of what certain meanings of words are. If you want more flashcards, you can have them. If you like. at least want you to have one for each operation or each symbol that we would represent with words.
What are you doing?
I feel about, you have a good amount? Okay. One at a time, we will come up, get some tape, and we're gonna place these words where they should be. So we'll just keep rotating, and if you see a copy, put that word to the side. So if you wrote equals, and she wrote equals, and you wrote equals, we're only gonna have one up there, we're not gonna have 3 equals. Okay? Or who can go first? Find the total. Is equal to. The product.
Product of same thing.
How many times? Difference. Is. What is the sum? Is the same as. Quotient. Multiplied by. Twice. I can go over them. It wasn't low in subtraction and addition. Equally. Take away. Less than.
You have no short?
All together. I like what you did there. You're playing off what I was gonna say.
We kind of did something similar to this in my class, when I said multiply to be groups of, but the teacher disagreed.
Multiply these groups of, and usually this division.
Multiply.
Would that be division?
Both.
Groups
It
of,
could be both.
explain,
Huh?
explain, curious.
3 groups of 5.
Oh. I always think of maybe those 2 groups are taken.
2 groups of 5. One.
Oh, got that. Added to. Goes into times. Much was
Alright. Do I have any more you can think of? Add? Okay. So now I really loved what happened here. All together. You saying it could go with any of these? So which of these can go with multiple of them? Because this is where it gets a little bit confusing. Whenever you look at word problems, which of these examples, product, less than, what is the sum, equivalent, added to, goes into how many times? Which of these, if you'd like to get up and look at them more if you can't see them from there, which of these could go with multiple? So I see a few. No.
I guess I don't understand your question.
So you have them in categories.
Yeah.
As in these are all multiplication, division. Are there any words that could represent multiple? Are there any? So
Find the total,
find the total.
could be multiplication as well.
Okay. Could it be anything else?
Beyond.
Why? Can you explain an example for big division?
Sure. You have 20 apples, you divide them over 4 children, find the total of apples each child will get.
Yeah, I like that. So find the total can you usually be used for all, put little asterisks for different ones. Do you see any others? Because you could see, what I'm trying to point out is you could see the ones with these asterisks on them in almost any type of word problem.
This might be silly, but if twice, could you consider that an addition as well? If like x plus x is equal to
Yeah. Yeah.
You almost, if you combine the different operations, for instance, take away, if you're adding, you can say, take away the negative of, take away the negative of.
Okay, explain that. What did you say? Sorry.
For instance, if I was adding, I wanted them to add 4 to 4, I could say, take away the negative of 4 from 4, which is adding 4 to them.
So,
If I want them to add a number, I can say, take away the negative of that number.
yeah, you can think of it in integers, and there's several of these that can be used in multiple. But I don't want you to be thinking in a very linear method as in this word has to represent that. And this word has to represent that. These are words that are usually found in these areas, in subtraction, equal, and whatnot. And all of you came up with them because of your past experience with word problems, and they're always scary. But they can be found almost anywhere. So, what I'd like you to do, well, first, I'd like to go over maybe some that you missed. Do we see maybe increased by? Could you, somebody tell me where increased by would go?
Addition.
Addition. Could it go anywhere else?
I thought you said addition.
You did. Increase by, could it go anywhere else?
Where you originally were putting it.
Could it go anywhere else? If you're trying to figure out the range of something, could somebody tell me what the range is?
Difference between the smallest number and the largest number in the set.
Okay, could you think about how much the set increased by? And have to use subtraction to figure that out as well?
Guess all you need to do is use it with a question mark. So the number increased by how much?
Yeah.
You subtract.
Increased by is,
Division two,
yeah, why?
percentage reason.
Increased by is like a special one, I always see it everywhere. And let me see, there's a few other good ones I wanted to show. I'm surprised no one said split or you kind of got into percentage with division for maybe the average. People always use average. I don't know if you can see this. And then I like everything you have for equals. Is equals to is the same as equivalent. You could also the result. The result is, or you could have even said are. Depending on how many you're dealing with. But with subtraction, with all these words, there's almost an infinite amount. With subtraction, you can say fell or diminished, reduced, grew down. There's an infinite amount of these. But what I would like you to do for your notes, this will get into how we're going to solve these different kinds of word problems. These are tables of your own. I would like you to fill out any right here or any more you could think of and try your best to think of exact word problems, such as if I were to think of subtraction, try to think of where you used it before, like range, or like figuring out temperature. Like try to think of instant cases where you see common problems that you would have to solve. And you can come up to the board and you can write these down. I would really like to have these in your notes. And what I want to get at is we're going to represent each part of these problems. So multiplication, division, subtraction, addition, equals to. We're going to represent each one with a color. And so addition will be blue. You can go ahead and mark that right now. Addition will be blue.
You want us to write with these?
Highlight over the word or box. Subtraction will be green. Multiplication will be orange or red, whichever one you have. Division will be purple or pink. And equals to or equal will be yellow. So what I'm trying to do is get you really familiar with a bunch of these words, have them grouped together where they should be. What I would say is for the words that can be used in multiple instances, write them towards the bottom or draw arrows to wherever they would be. And what I would also do is maybe highlight words that would be used all over, like increase by. Do a mark of blue, do a mark of pink or purple, just on it. So you know it's a multicolored word, you could see it anywhere. So this will help you really figure out where these words should go, or what these words mean whenever you're looking at them. As you keep working with them, you become comfortable and not even need this table anymore. And if you can't see, feel free to come to the board. Anybody think of any new ones? Any new words that were not said? What do you got?
Well, for subtraction and, I was thinking of like you said temperature, so I was thinking falls, like if the temperature falls to 10 degrees, what is the new temperature?
That's good. And so what would be the addition version of that temperature?
It rises.
Okay, so does everybody have a table pretty much filled out to where you're comfortable with? Where you could look back on it and help yourself later? Good. So what it says up there, Jordan, go ahead and read that for me, please.
The difference of a number x and 8 equals -5.
Okay, so what do you think I'm gonna ask you to do?
Right.
That comes later. Yeah, I wanted you to use these colors for a reason. What I want you to do is I want you, someone who would like to volunteer, either that or let me do an example first. I'm gonna ask you to color code each part of the problem so that you know what to pull out, what's fluff, and what it's basically asking you to do. And whenever you write your numerical form, you're gonna color code that as well. So you can see where these numbers and where this operations match each other. So what color did I say, what color would I use for difference?
Green.
Green, which is, what's the difference?
Subtraction.
It's not green.
Other.
Difference. Okay, so we know it's subtraction. The difference of a number x. What is this telling you, number x? We didn't show it on the table because it's not an operation.
So bigger.
It's a variable. And what is a variable?
Unknown,
Anybody? Yeah.
unknown number,
An unknown number. It could be
negative, positive.
negative, positive, anything, infinity.
Yeah.
Okay, so with that, we are going to highlight, I did not pick a color. With that, we're gonna underline. Underline a variable that we see. It's a number x. And then, what else do we know about this problem? We know our numbers. What are some other action words that we've seen here?
Equals.
Equals. And so what color would equals be?
Yeah.
Yellow? Equals. Now who can tell me the two numbers, the known numbers that we know here?
8 and -5.
8 and -5. Now how do we know what order this is gonna go in? left to right, just like you're reading. It's almost easier to see that you can go left to right in a sentence than you can in a numerical equation. But so you need to understand what to really write down first. So if you're going left to right, what number will we write down first numerically in a numerical equation? Number or
In this equation, x.
x? X, okay. So now what operation are we doing between x and the next number? Subtraction. Good. And so what other known number do we, what other two known numbers do we know?
Negative
8 and negative 5. Okay, how do we know which one comes before or after the equal sign?
5. Because the 8's before the equals in the sentence, so it goes before the equals in the equation.
Exactly. So we would do your R8, and then what comes after that, Jordan?
Equals,
Equals. Negative or positive?
negative.
Negative 5. Now, this will be helpful when we're checking our answer and whatnot. We know that the difference, action word right there, of a number x, our variable, which we underline. And then what other action word do we have here?
Equals.
Equals. Now highlighter equals. So we know that we pulled the important information out, the important operations out, and we got it in the correct order. Which, how do we follow the order again? How does the order go?
Left to right.
Left to right. Great. So just like you read in a sentence. Now what I would like you to do is I'd like y'all to pair up, since we only have 3 people, we're gonna get a 3-person group. And y'all are gonna come up with, no wait, we're gonna think, pair, share here for a second. Who knows what think, pair, share is?
I do.
What is think, pair, share?
You think about it for a moment, then you talk about it with your neighbor for a minute, and then you share it with both sides.
Okay, so that is exactly what we're gonna do. We're gonna think, we're gonna write our own small one-step equations using the action words that we have here. And then talk it over, make sure it's okay. We're gonna present it in front of the class. Don't try to solve it. Don't write the numerical form just yet. But we're gonna put them up here, and we're gonna try to do them together with the class. Okay? Does everybody understand? Okay.
Sum of 5,289. Let's make this hard.
7th graders are creative.
We just create one total, right? Or we each make one.
You want 3 at least.
Oh,
So yeah, each person make their own, and then you talk. So you think and pair up, and present in front of the class.
We can only make one step.
Yes. You haven't learned 2-step yet. Yeah.
Just one step. You got it. Really hard.
You draw a circle and then hit the middle. Step. That one you actually have to read.
everyone have their,
Yes.
okay, talk about it, talk about how you probably start off by going to solve this problem. What process did we use and how can we replicate it with your problems?
Couple of them.
It's only qualified, I wrote the sum of 5,289 and negative 493 is equal to 19 squared minus twice the difference of 29x.
We're doing one step.
Okay, so my real one is the sum of x and 15 is 10. The sum of x and 15 is 10.
What's our choice of number is 10?
That four more than a number is -9.
Everybody comfortable with their problems? Okay, Jordan, what was yours?
Twice the number is 10.
Okay, is number represented by anything?
A variable.
What is the variable?
I'll do J.
J?
Yeah. J. Yeah.
That's pretty. J. Is 10.
Do we always need to have a variable?
No. No, you don't always. You could be asking, what is twice the number 4? You could be asking, what is, you could literally be asking, what is 18 times 3? You could be asking any math problem that you can think of that you've been shown numerically, like 3 plus 2, you could say 3 plus 2 and write it out, or 3 added to 2, or 3 combined with 2, or you could use any type of words. You don't have to have a variable. You could have,
I think his question is, do I have to name the variable?
Right, in that question, why couldn't we just say the number?
the number could be up with interpretation. You could use any variable you would want. I just wanted to label the variable so we'd all be on the same page.
Okay, yeah, that's right. I guess if we're going to put it in algebraic expression, we do need a variable.
Yeah. You could, I mean, in an algebraic expression, you could have a blank space.
Oh, good.
Or a
Could
box.
each of us choose a different one?
You could.
Yes, yeah, I was just curious to know why did we put a variable in that?
Would you like to have an emoticon of smiley face? Would that make you feel better in 7th grade?
Be a flower.
Be a flower? Flower.
Like a handbag.
Y'all are killing me.
Good.
Money sign.
The name names capital J is a smart face anyway, so. jokes on
Oh,
you.
yeah.
Okay. So, Ruben, I'd like you to come up and write this problem numerically, but first, I'd like you to follow our process of color coding. And why green?
Let's see.
Undo.
Where's it?
Undo. Yeah. Just click outside.
Twice. That's a weird representation, but we always know twice is how many? Two. I like it. But if you can write it however you like, if you want your parentheses, you could do a line of, well, All I'm doing.
That's what there is there.
You can put wherever you see the multiplication.
That's what I see.
That looks good.
Okay. Good lights.
Have you done the lights yet? Here, I'll do it. Is that better? So yes, what Ruben did is twice means what?
2 times.
2 times. So what operation is that?
Multiplication.
Multiplication. And he underlined his variable, and he didn't forget about the is. The is such a small word, you forget about it all the time. I like that he actually highlighted the is or equal sign, and then wrote down his other known number, which is 10. So good job, Ruben. But if you'd like, underline that variable again. Okay? Jordan, what was yours? Or, no, Ruben, what was yours?
The sum of x and 15 is 10.
The sum of x did it a little bit different this time. Dr. Hughes,
Yeah. Sure.
come and work on this. Okay.
Am I writing it down?
Well, she did very good. She picked out the sum, so you know what operation is it?
Addition.
Addition. Her variable underlined, so she knows in what order her variable needs to be, but with addition, does it really matter what order it has to be in? Why is that?
The
Commutative property. Yes, now with subtraction, in the first example, not Jordan's, but before, did the order matter then? If you'd like to remember, it was the difference of a number x and 8. Yeah, that you have to look at subtraction, that order really matters. Now with your example, did the order matter, Jordan?
No.
No. Why?
Community property is multiplication.
Yes, perfect. Now, and then the 2 numbers that are being shown that we know, doesn't always have to be 2 numbers, but the 2 numbers that we know are what?
15 and 10.
15 and 10. Okay. So let's just, for order's sake, let's write it as it should be, order left to right, as we learned. And that's very good. Awesome. Underlining the variable, blue is addition, represents the same thing. Yellow is equals, represents the same thing, is and equals. And we have our known numbers. In the correct order is we learn left to right, just to read a sentence, just as you would normally read an equation. But numerical equations are kind of difficult whenever you start solving for your variable and whatnot. It's not always gonna be a bland left to right, just like you read. And what, also we did something different here with the numbers. If you'd like to look. I don't have the first example. So in the first example, I typed in my number normally as a 10. Oh, a 10. And I could have written that as just a 15. You're not always going to see, unless you have probably really big numbers, you're not always going to see numbers written out. Now, Dr. Hughes, would you like to show your example?
Sure. 4 more than a number is -9.
Oh, you weren't supposed to go there. 4 more than a number is -9. And Jordan?
Alright. This is blue, right?
Yeah.
Awesome. Addition blue, just like we did. Underlining the variable, but there's no variable representation, so it could be anything you want. For your sake, it's great. You could do an apple, handbag, flower. And then is equal, just like we did. So we represented it perfectly color-wise, underlining our variable. Now, if you can, write it numerically.
I'm gonna highlight it too.
Awesome. So, again, what this is telling you, what the colors, what the purpose of the colors is, and what the purpose of the underline is, it lets you know where this came from. And so, some people look at word problems, or might look at word problems, and they might see a big jumbled mess and they don't know, and they see somebody write it out mathematically, and they might not know where they got whatever it is. So order-wise, is this correct? Yes.
What if you wrote that problem, except you put in less than
Less than.
instead of more